So module 5 is about vSAN storage policies. Okay. So that's one of the important module while we are planning for our capacity placement of the objects, components. Okay. And kind of where we'll see overall how we can optimize the capacity and how we can reclaim the space as compared to traditional storage, and which storage policy gives us the benefits with respect to performance perspective, with respect to capacity perspective. Okay, that's all we are going to discuss in this module. And how do we apply them? Okay, how we can change it, what is the default storage policy available, what are the customization options are available, what are the different options are available when you configure the vSAN storage policy. Okay, so a lot of things and pretty much important itself. So first of all, we will understand what is vSAN object and components. Then we'll talk in details about all kind of storage policies and their integration with vSAN, and describe the steps of creating the vSAN policy and also applying the vSAN policies on virtual machine and its objects. Okay. All right. So first of all, let's understand how my data got storage inside the vSAN data store. Okay. So when we say the vSAN data store, so vSAN itself provide the object-based storage. Okay. When we say the object-based storage, it means that the whatever we are writing inside the data store, okay, that unit is object. That unit is object. Okay. I think my touchpad is misbehaving. Sorry for that. Let me just disconnect my mouse. It should work fine now. Yes, absolutely. Object. So objects are my virtual machine namespace, my VMDK file, swap file, snapshot, memory snapshot. So all these are the different type of objects that's being stored in the underlying storage. When say underlying storage, inside the vSAN data store. Just let me ask you one question. Can we create more than one vSAN data store in a single cluster?
I've not tried, sir.
We can't at all.
Okay.
Okay. It's always one vSAN data store. Okay.
So we cannot, sir.
No. You
Okay.
can. Okay.
We can. Okay.
You cannot at
You
all.
cannot. Okay.
Yeah.
Okay. Straight
Always a
answer.
single data store, and within single data store, maybe sometime you will think I have different set of disk. Let's create two vSAN data store. Actually, whatever you are achieving by creating two vSAN data store, that all you are achieving in a single vSAN data store. That's why you don't need to create the separate. Okay. So when we say different type of objects, so these objects further divided into smaller piece of chunks, and the smaller piece of data chunks are called components. Okay. Components are the actual piece of my data that is being stored finally in my disks. Okay. You can see component 1, component 2, and the third is component is working as a W stand for a witness. Some of the storage policy where you find my witness component will store, that's a behave like as a quorum. Okay. So whatever the kind of objects I am storing, I'm placing the object, end of the day, that's converting into the components, small piece of component. And how these components are distributed across multiple disks, okay, across multiple nodes. That all matters on my storage policy. Okay, that all matter what kind of storage policy I have applied on the top of vSAN data store. Let me clarify you one more thing here. It's not a, when we deploy any kind of storage policy, it's not a kind of traditional method like use in a physical server. If you make a RAID one, what happens actually? Underline physical server. If you will make RAID one, what it do? It pick any of two disk, right? Configure mirroring and configure RAID one. Correct? Like that. Have you ever configured on physical server RAID? RAID on physical server level? No, yes,
No, no, sir.
no. Okay. So any kind of enterprise server you purchase from the market, it's kind of Dell, HP or something like that. You can select the underlying physical disks and you can configure RAID. So this RAID is applied on the by your hardware management. That's by BIOS itself. Okay. So what that will do, like you choose two disk, you configure RAID one there. So what it will do, it will write data directly physically on it. Okay. But within these two disks, I cannot use any other type of RAID because the RAID, what you have applied here, that is on disks level. Okay. That RAID is on disks level. But here in the vSAN environment, RAID will not work like the traditional method. That RAID will apply on the object that you are storing and further split your objects into small chunks of data that are my components. Okay. Bear with me. I don't know what happened with this, my digital touchpad. It's not
Okay.
behaving correctly. But
Oh,
focus on
okay.
my words. Okay.
Sure, sir.
So
Sir,
when we,
in case of,
yeah,
sorry, sir,
yes,
in case of RAID 1, for an example, the witness component will still be created, right?
uh,
Or,
yeah, there is certain situations where witness is mandatory. In certain policy, witness is the mandatory. In certain policy, witness is not created. Especially when we are configuring types of RAID 1. Within RAID 1, witness is always a mandatory component. Okay. But
okay,
when we are configuring kind of erase coding, RAID 5, RAID 6, witness is not required there because they themselves create a kind of parity somewhere or another place where actually your data being stored. So that point of time, your witness is not mandatory. Okay. Simply when we do in high level, that's we are covering. RAID 1, witness is mandatory. Any kind of policy we are applying with RAID 1, but any kind of policy we are applying with RAID 5 and 6, witness not required.
okay,
Why?
okay, sir.
Because that create their own parity. That behave just like a witness. Okay.
Okay,
So that's what I was trying to explain here. Whatever the data you are writing inside your VM, it could be your VMDK, it could be your VM object file, it could be Delta file and all. That's all managed by some kind of storage policy. End of the day, whatever storage policy being applied, data being stored in the underlying storage. Could be anywhere, like it could be component, it could be witness. Okay. So it's all depend the kind of storage policy what we have configured, right? But again, I am repeating my word. A storage policy is not as similar as you do in a hardware environment, kind of your physical server level. This RAID capability, this storage policy capability is not dependent of any kind of RAID configuration under your physical server. It is the vSAN native feature. It is the vSAN native feature. Okay. It doesn't matter whether your underlying hardware supporting RAID or not. That's not a matter, because that's a feature that you are applying on the software layer itself. It is not kind of hardware layer, right? So it is just telling you how to create a storage policy. It's pretty simple. You will go on menu, then you will find storage and policy section. From there, you will select VM storage policy. Then you will get a tab of create. Once you get a tab of create, it will ask you the policy name. Here you can put some of the description about the policy. Then when you will start to create the policy, you will get a lot of options. That's the important thing we have to understand, like site disaster tolerance or failure to tolerate. So here, if you will see number of policies, you will find host mirroring with 2-node cluster, non-standard cluster, where we are saying we don't have too many nodes to sufficient for applying the kind of RAID 1 and site mirroring, that is primarily when we are planning the stretch cluster. Keep data on preferred site, keep data on secondary site, non-stretched cluster. Okay. So this is the type of site disaster tolerance, how we are planning. Okay. If we are planning for standard cluster, we have to take as an standard. Then failure to tolerate method. Failure to tolerate means how we want to protect the data locally against any kind of disk failure or node failure. When we say
Sir,
yes, please.
these like, can you explain like non-standard cluster? What is a non-standard cluster? Host mirroring to how is it that like in a real-time environment? Like how will it be like?
Yes, definitely. So when you say non-standard cluster, it means that, see, there is two section. Okay, site level failure, है then second is failure to tolerate. So here you have choose non-standard cluster. It means that we are not talking about kind of any stretch cluster, kind of one node. Okay, the smaller one. We are talking about a cluster that is hosted in a single site. That is hosted in a single site, single physical location. Okay. Then if you are saying host mirroring 2-node cluster, it means that we just want to define where we have only applied 2 nodes and still we wants to do the mirroring. Okay. Mirroring of data. Site mirroring stretch cluster. It means that we want to apply the policy, a cluster, a single cluster, which is stretched between site 1 and site 2. It means that whatever data being written to any of the VM, that data will create 2 copies. One on site 1, one on site 2. Okay. Now it is saying is still your cluster is stretched, but your data should be written on primary site only. It means that cluster is stretched, but its mirror copy will not replicate to secondary site. Same way, keep the data only on secondary site. Okay. Only on one site. None stretched cluster. It means that wherever your actual VM is reside, means your cluster is still stretched, but if my VM is running on site 1, it will only write the data on site 1. It will not make a copy of site 2 itself. Okay. So now you will ask, sir, then what is the difference between this and this? Obviously, because if you think keep the data is stretch cluster preferred site and keep data on second, the main difference here is if I will say preference is site 1, it means that my VM can be hosted on any of the site. But still, if I select this option, my actual data will be stored on particular site, whatever I have given as a preference. So the first part of it, that's telling you how you want to protect the data within the stretch cluster and non-stretch cluster. If my cluster is not stretch, it means that I have to plan some policy how data could be protected locally. How data could be protected locally. Okay. So, Banu, just allow me some time. I'll explain you in very much detail also. Don't worry. So let's first understand. Yeah, let's first understand how I can protect my data within the local site. Okay. Then I will go across the site as well. Don't worry. Okay. Just allow me some time. You'll definitely be covering that.
Yes, sir.
So first of all, let's understand the policy definition. Then I'll come on to node, stretch and all. Okay. So if for any policy definition, if I will say I have applied a policy within, I'm talking about within local data center. Okay. I'm saying I have applied a policy RAID 0, FTT 0. Okay. So it means that it is just like as a simple data I do protect in the environment. It means that whatever I am protecting, that will only make a single copy. Single copy means a single component for that object will be storage, will be stored. Does it have any redundancy like component 2, like witness, just for quorum purpose? Answer is no. Okay, where we are saying FTT 0, RAID 0. It means that failure to tolerate 0. It means there is failure tolerance is 0 with RAID 0. It means that I'm not doing any kind of mirroring or kind of that. Okay. That will ask you, sir, where we should apply this policy, where we don't want any data redundancy, especially. Okay. Something where we have configured application level of clustering, non-persistent VDI environment. Okay, non-persistent means one-time use. You are accessing it, use it, and next time if you will use it, a new VDI will be provisioned for you. Where either we have the application level of redundancy, I am using some just development data. I am not focusing more on the data redundancy itself. I can recreate that, or some kind of VDI environment. So these are the some use cases where I should follow the RAID 0 with FTT 0, where I can definitely, you will get sufficient space efficiency because you are not making data copy, witness, blah, blah stuff. Okay, you are just making the original data copy. If your original data is 1 TB, then it will only consume underline 1 TB. Okay, we good so far?
Yes, sir. Yeah.
All right.
Yes, sir.
Yeah. Now let's understand the next level of policy. That is my RAID 1. But within RAID 1, we got different level of FTTs. I mean, say failure to tolerance. So first, if I will apply, I will make a policy FTT1, failure to tolerate 1 with RAID 1. What it means? It means that whatever object, on which particular object you are applying that policy, that will create 1 copy plus 1 mirror copy of that component, what is being written inside underlying storage, plus that required a witness. That witness is not your actual equal amount of data. That is 5 MB of data that is working as a quorum. Forum means is just monitoring my environment is health. Okay. But definitely that will create these component on different objects. Okay. That is my FTT1 RAID 1. It means that by XYZ region, if this entire node got failure, my data is still safe. Still my VM in a function mode, but definitely to which object this policy being applied. Let us suppose for I have applied this policy for VMDK1. It means that my VMDK1 still accessible, but there will be a warning symbol on the redundancy itself. Reason is being you have lost the redundancy. That point of time, that's why yesterday I have showcased you like when you apply the RAID 1 FTT1, minimum node is 3, recommended is 4. Why recommended is 4? So that if I'll bring in picture 4th node, it will start recreating the mirror copy of this component. That's why they have recommend there should be 4 nodes. Are we good so far? We clear on this set
Yes,
of?
sir.
Okay.
Yes, sir.
But still, we have that warning symbol, right? So if we add fourth node also, we'll be having one warning symbol, right?
No.
No.
So yes, let me tell you. Automatically, it will repair the entire object within 60 minutes. 60
Okay.
minutes is the time to repairing the object. Once you will bring a 4th node, after
Okay.
60 minutes, you will find that data resync start automatically and your warning will go away.
Okay. Okay.
Okay.
Yes. But the back end, we have to work for the first node, which is from having hardware issue.
Yeah. So that's what he have just explained here. The method what I told you. Somewhere it will like the any of the object you apply the policy like just one moment. Here you can see namespace. Like for namespace, you have applied the policy to component 1, component 2. You can see component for VMDK you have applied different policy, and for swap you have applied the different policy. Okay. Now it is telling you in any of the case, if let us suppose this got failure, this got failure. Are you still safe? Yes. Component 1 redundancy is component 2. Component 1 loss here. Redundancy is component 2. Witness is lost. Still my component 1 and component 2 are in the healthy state. Correct? Clear? But it told object, your object is safe, but you have reduced the availability. Okay. So for that, you have to onboard a new node so that on that new node, your component 1 will rebuild, component 1 rebuild, witness will rebuild. Okay. Got it? So to make the environment healthy, you require more than 50% node should be accessible. 50% node means simple example. We have 3 node configuration. If any of one node goes down, still you are safe, but in warning state. That's what say more than 50%. But if this also loss, this also loss. Okay. Am I able to access my data? Answer is no. You cannot. That's why it say how many candidates we are using. More than 50% votes should be live, up and running. Like in 3, simple example. If my 2 components are okay, I mean two nodes are okay, my data is accessible. 1 got down, that is fine. If 2 got down, 1 is okay, then you are not able to access the data at all. Clear? Like this. RAID 1 FTT1. That's why the name is FTT1. If you lose more than 1, you will not be able to access the data.
And
Okay.
the data gone. Okay.
Data will go. So now it's trying to tell you like now Okay, it directly goes to how my data consumptions happen across these policies. FTT1, if I will configure RAID 1 FTT1, how much data you assume should be stored? I mean, how much storage it will consume?
Double, sir. I think double
Double
should
of
be.
that, 200%. You are absolutely right. Okay. So if I am writing some 10 GB object over FTT1, RAID 1, it means that I required underline, it will consume 20 GB. Okay. Now let's talk about the FTT2. FTT, oh, for that, yeah, I need a blank slide. That will be good. Let me just take a new slide. When I say FTT2 RAID 1, it means that one node, two node, three node, four nodes, five nodes. Okay. So let's assume these are the underlying storage. This is the underlying disks. Okay. Just assume a set of disks here. These are the set of disks. How it will write the data in FTT2 RAID 1? In FTT2 RAID 1, it means that it will create, if I'm writing some data here, first it will create original copy, then it will make two mirrors of that. Two mirrors. So it means that your three data copies and two witness. Three data copies and two witness. Okay. Again, witness will not take much space. These are some just quorum files. So again, if I'll take an example of 10 GB, my consumption would be 30 GB. Okay. But in this case, I can bear any of the two nodes failure. Still my data would be safe. Correct?
Yes,
But
sir.
again, I am getting 1/3 of actual storage because my consumption is 3 times now. If I would say FTT3 RAID 1, now you can assume how many? One original copy plus three mirror copy plus
Yes.
three witness.
Witness. Three
Okay.
witness. Okay.
So in that case, bare minimum I required 7 nodes. But how many failure it can tolerate in parallel?
Three.
FTT 3. But practically, if you will ask, sir, will anyone will apply? I don't think so. Anyone wanna go with 3 nodes failures with this one? Okay, because it's going to consume your 4 times of storage. Like if you are writing 10 GB of data, it will be going to consume 40 GB. Okay, then you have to plan your capacity up to 400 times against the original data. Okay.
This is very critical situations.
Yes.
Okay, means critical applications. We can clusters. We can do this
Yeah,
kind
it's still like if you'll go up, still you can maintain 2 parallel failure here. So, yes. So that's how these FTT policies works with FTT1, FTT2 and FTT3 with RAID 1. Okay, so these slides try to explain the same thing, what I was just telling you. Okay, FTT2, VMDK2, RAID 1, FTT2. Like when you will create FTT1, C1, C2 witness. When you will create FTT2, then you will see C1, C1, C2, C3, 2 witness, and my capacity is 3 times. FTT3 components C1, C2, C3, C4, then 3 witness. Okay. But keep in mind, like when data will writing happen, maybe let's assume an example here. I'm writing some data in a disk. My C1 I have created on this, C2, C3. Maybe next time it will be C1, it could be witness, it could be C2. So it's a dynamic process. The placement responsibility will be your, that is the intelligence of vSAN, how that is writing, okay, the data, how that is writing the data. It means, see, again, it will not follow against the same pattern. Maybe on the next time, it will write C1, C2, C3 in another places, and the 3 witness on another places, okay. Or this is my bare minimum. Like when I say the RAID 1 FTT3, I required bare minimum 7. If I have 14 hosts, just assume an example, within 14 hosts, I'm applying this policy. So it means that if it will follow the same pattern, it will only consume the first 7 hosts. It's not like that. It's always dynamic. Maybe this time I'm writing my object that is going another 7 nodes. Maybe next time that is going another 7 nodes. Maybe next time my C1 will create it on node 1. Maybe next time my C1 will create on node 2, node 3, or node 4. Anyone. So it's always kind of intelligence of vSAN that do balance the underlying storage. Correct? And again, within same data store, I can create different set of policy, like for this one, this one, this one. Then again, vSAN is smart enough that will do the equally distribution of data to the underlying storage. All right, we good so far?
Yes, sir.
All right. So
Yes,
now
sir.
let's understand about the RAID 5 as an eraser coding, where we refer as FTT1. But FTT1 is again will protect you with one node failure. It is equals to your RAID 1 again. But it somewhere it give you the storage efficiency. How it's giving the storage efficiency? It works in 3+1 mode. When I say 3+1 mode, let us suppose you are writing a data of 10 GB. Okay, so that will be divided by 3. So it will make like 3.3 as a C1, C2, and C3. So it will split it into 3 strips, plus it will create a parity. So parity is nothing, just a mathematics again, a logic that if any of the component got failure, along with these components, this parity will regenerate it again. Okay. But again, for regeneration, you required at least one more additional host. That's why they said with FTT1 RAID 1, you can maintain one node failure one time, not two node. Mere minimum requirement is 4 because its writing mechanism is 3+1. Recommendation is 5. Why? Because let us suppose this example. If I would say, or let me see next slide, they had showcase. No problem. Let me go back. If I would say this node got failure. So if this third node got failure, is my data protected? Still, am I able to access my data? Answer is yes, because along with this and this parity will generate your data. Here is also my data fail. Then again, this parity plus these two data will generate the original data. Here my data fail. I'm going like that. This data plus this parity would be survive my data. This parity fail, my data is still available for rest of 3 nodes. Okay. My data is still safe, but with again warning symbol. Redundancy. I don't have the sufficient redundancy now. If In future, I will lose one more node. Any of three, my data will be completely lost. Okay. But if this is permanent loss, this is a permanent loss. If I will onboard new node with same set of configuration, and I have at this group and all. So it will regenerate all my lost data. Wherever parity, data, data, data. So Banu, this is answer your question first for witness. Here parity bits are worked as a witness. But
Yep.
if you
Okay.
will ask me, sir, after taking 10 nodes or maybe more than that, can I do FTT2? Like logic comes in mind, like for node, I am maintaining FTT1 RAID 5. If I'm writing on 10 nodes or maybe on 8 nodes, can I do FTT2 with RAID 5? No. Answer is no. Because your data writing pattern would be still same. Okay. Your data writing pattern would be still same. It will not like it will write 3 plus 1, again 3 plus 1. You cannot get two fail tolerance. Only one failure to tolerate with RAID 5. But again, you will ask me, sir, that is okay. But sir, you tell me कि यार RAID 1 maybe I am getting FTT1 with the same one, and here also, what is advantage I am getting here? Definitely you are getting an advantage. While you are writing the data in RAID 1, FTT1, FTT2 or FTT3, that's always equivalent. Like when you are writing RAID 1, FTT1, it means that your equal chunks of data go here. 10 GB, 10 GB, like that. Okay. If you are writing 3 times FTT2, then it is 30 TB, kind of that. If you are writing FTT3, that is equivalent amount. But here, you are only on the original data, you are only overheading the 33% on the top. It means that if there I am writing data in FTT1, RAID 1, which was my consumption was 20 GB. But here, as compared to that, when I am writing the data in FTT1, RAID 5, my consumption is only 13 GB. 33%. More than original data, just 33%. Why I'm saying? Like I've given you an example, 3.3, 3.3, 3.3, 3.3. That's it. Because this parity is a generating just a mathematical calculation, something from here, something from here, something from here, and it can regenerate the data, it can regenerate the lost data. So within RAID 5, if you compare, I would use only 133%, or simply you could say 33% more than original data as compared to FTT1 RAID 1. All right. So here you are getting the storage efficiency. But when we will use kind of eraser coding, definitely there is some minor impact on your host's performance, data read and writes, because here write mechanism is bit complicated. If you will see the mathematics of writing data, like you are bringing up 10 GB, you have to split that. Okay, your system have to do some calculation. You have to split equally, then create and generate the parity. So while you are writing the data in eraser coding, maybe you will not get the equal level of performance that you are getting in the RAID 1. Okay. So from storage optimization perspective, if we compare FTT1 RAID 1, FTT1 RAID 5 is better. But if we talk from performance perspective, FTT1 RAID 1 is better than FTT1 RAID 5. Clear?
Sir, in terms of reads and writes,
Huh.
does that also like affects like how the
Yes,
data is written in.
absolutely. Absolutely. That goes affected. Because if I'll compare to the previous slide here, just let me go one more slide back. Whenever I'm reading the data, this is the entire set of file, right? Entire set of data I'm picking one time here, okay? Like this is my 10 GB, for example, okay? So I'm picking the entire chunk one time here. But if I'll compare with RAID 5, this 10 GB, I have to pick from multiple places. Got it?
Yeah, yes, sir.
Because that is in a distributed manner. That's not placed on one particular block or one particular container, I would say. Okay. So next eraser coding is your RAID 6, where you can get FTT2, failure to tolerate 2 with RAID 6. Okay. So how many component you required again? Here you required 4 plus 2. When I say 4 plus 2, 4 data component plus 2 parity. Data, 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 parity, parity. So here you can tolerate 2 failures simultaneously. Okay. And what would be data overhead? Data overhead will go to 50% more. Okay. 50% more. It means that if you are writing 100 GB data, then it will take 150 GB on your disks. But the advantage over RAID 5 is you are getting 2 failure to tolerate. Okay. But disadvantage is more space as compared to FTT1 RAID 5. And if we'll directly compare with the FTT2, FTT2 RAID 1. So in FTT2 RAID 1, how much it will take? 100 GB. How much it take? When I will write the data 100 GB in FTT2 RAID 1,
300, sir.
300. Absolutely. Okay. But the same data, if I am writing in FTT2 RAID 6, how much it's taking? 150.
Yes, sir.
Correct? So you are directly getting the 50% optimization here. Correct? 150,
Yes.
300. Any chunks you will take, same ratio will work. Okay? Because you cannot compare it with FTT1 RAID 1 because we have to compare somewhere we are getting the equal level of redundancy. Okay? But again, when it comes to performance is bit slower as compared to FTT2 RAID 1. Why? Because in FTT2 RAID 1, it is picking the entire component from one place, but here it have to collect the data from different placeholders for read and write purpose. That's why. Now you will ask me, sir, then where we should use it? Where we should use this, where we should use that. Okay. So especially when you are using general purpose workload, operating system drives, and kind of infra apps, AD, DNS and all, then it's good to keep your data on FTT1 RAID 5 or FTT2 RAID 6 itself if you want to make more redundancy. But especially for when you are planning for storage policy, especially for your where you are writing data so frequent, higher IOPS, like your DB servers, lot of queries coming, going back, Exchange server, your file server, kind of SharePoint. That time, we would prefer to keep them with RAID 1 volumes, either FTT1 RAID 1, or if you are looking more redundancy, then you can make FTT2 RAID 1. So that point of time, somewhere you have to negotiate. Negotiation is on the space side. If you are trying to achieving the performance, then you have to give more space. And if you want, actually, I am okay with the performance, what I am getting, but somewhere I want to optimize my storage, then you can apply the FTT1 RAID 5 with the laser coding on FTT2 RAID 6. Okay. So as of now, these are the set of policies are available. If you will say, sir, can we apply kind of RAID 10 or combination of RAID 6 plus 0 RAID 6? That's not possible altogether in vSAN. And again, repeating my word, within vSAN, it's not like that the RAID is not applied to the disks level. Your storage policy apply on object level, and your vSAN smart enough for the placement of your data components that will equally distributed to among the particular nodes that we are taking in the cluster. But definitely there is some bare minimum requirement to apply certain set of policy that we have to keep in mind. Okay. Like in RAID 1 FTT1, it said you 3 host, RAID 1 FTT2 5 host, RAID 1 FTT3 7 host. But the recommendations to go from your side when you are planning for the customer. Tell him, hey, Mr. Customer, if you are planning RAID 1 FTT1, my recommendation is to go with 4 host, so that by any chance you are one of the host in maintenance mode or maybe by shutdown and all, so that you can easily recover the failed component. Okay.
Yes, sir.
Not the
If you-
failed, the warned component actually.
Yeah.
Yeah.
Yes, sir.
So where you
So
want
for
to,
RAID 1 FTT2 also we'll have 6 is a we can by
recommendation
recommend
is
it
6, minimum 5.
Uh,
Okay.
Sure, sir. So this same apply for RAID 5 FTT1 also.
RAID 5 FTT1 minimum 4,
But safe side you
recommendation
can
is 5.
keep 5.
Yeah.
Yeah.
Whatever numbers you are seeing here, just add 1.
Yeah. Okay.
Okay.
Yes.
As in recommendation.
Sir, there is no RAID 6 FTT1, right? No, the concept is not.
No. RAID 6, RAID 6 is always dual redundancy. Even you will do an hardware RAID itself, there is 2 core. Okay. RAID 6 is always with FTT2. Okay. So now there is some advanced policy configuration also, along with, like, now I am clear what kind of policy I have to take for what kind of object. Now there is additional set of policies also, like if you want to keep data strip. Strip is mean again a small chunk, like if I am writing a component, by default, a component place in one data strip. But still, if you want to split this component into 2 strips within one disk, that's also possible. Okay, this strip number can go 1 to 12, but normally people don't touch it, just keep it as a default. IOPS
Can
limit.
you repeat once again, sir? Please.
See, one component,
Okay.
when you are writing one component, it will place under one block. You can say simply under one logical block.
Okay.
But if you will say, I want to further split this component into 2 blocks, you can within a particular disk.
Okay.
Like for example, this size is 5 GB. Now you are saying, I want to make 2 strips, then 2.5 will place here, 2.5 will place here, but that will be within a disk. How many strips we can create? 1 to 12, you have the option. Okay, but as more as strips you will increase, somewhere your performance will impact.
Yes. Again, it has to get collect all the details and then give.
Absolutely. IOPS limit per object you can define. If you are feel some within this policy, I have some of the VMs which are IOPS hungry, you can define. Object space reservation, that's something you can apply here. Thin. So when you create a virtual disk in simple storage, you have seen disk type there, na? Thin or thick, okay? But when you will create any virtual disk in vSAN, you will not get disk level configuration there on the virtual machine setting. Here, that is itself part of your storage policy. Within thick itself, you can define 25%, 75%, 100% kind of that. Flash read cache. So it is especially you are reserving some of the flash, especially for read purpose. But this is applicable only when you are configuring hybrid mode. When you are in already you have the capacity drive and cache drives already. Disable checksum. Checksum is by default enabled. Checksum is simply the internal repair for your objects. Okay, any error it will fix it automatically. And if the checksum is being available on a particular application, you can disable it. But if this checksum object checksum is not enabled, you can keep it as enabled. It's a good practice. Force provisioning. What is it? Force provisioning. When we say force provisioning, it simply means you are saying कि Kuldeep, you told us कि यार we have to apply the vSAN, like for example, you are here. Okay, RAID 1 FTT1. But you are saying, Kuldeep, yaar, I only have 2 nodes. But still, I want to apply FTT1 RAID 1. Okay, then you can choose an option force provisioning. It means that as per best practice, it should go like that way. Component, witness. But here, I am having only 2 hosts, 2 ESXi hosts. If I'll enable force provisioning option, it means that it will create, because you are forcifying your machine to create the FTT1 RAID 1. It will create, that's not a problem. It will create all required component, but it will not provide you the guarantee of failover, because you have forcefully put 2 components on one placeholder. That is why my force provisioning. If you
So
just
what is the
test,
default? What is the default one? So we disable in better option.
yeah, correct. It is
Okay.
only if you want to test. If you want to test the policy apply, that's it. But it will not give you the guarantee of failover ever. Okay. So this is the one what I was trying to tell. The default value is 1. Scrapping you can go. Okay. But we should keep it as by default. IO size for IOPS limit normalized to 32 KB of size, because this will affect per object. Try to understand. It's not per entire per object. Okay. IOPS use cases like you want to give certain priority to the applications for the higher IOPS that you are running under that policy, then you can apply it. Object space reservation. Space reservation is again the policy where we are selecting the thin and thick, right? So in thin, will it reserve some of the space? No, because thin is something, whatever we are consuming, it's consuming the underlying storage space. In thick, what you understand about thick from the earlier? Simple without vSAN. When you create a disk, it will consume the entire underlying storage. Either you are writing the data or not. That was thick. But here, thick is more granular. You can reserve 25%, 50%, 75% of that. Okay. So if dedupe and compression you have enabled with that policy, space reservation is limited to thick and thin directly configuration. When I say thick means is directly 100% reservation, or thin means no reservation by default. Whatever the data will be written under the underlying storage, that will consume. But if I'll say thick direct, it will consume the 100% space, whether you are writing the data or not. Then flash read case, as I tell, if you want to increase the read of the VMs, if you are using hybrid configuration, then you should enable it. And if you don't want, your application is not read intensive, just keep it as it is. But if you are using all flash array, then you don't need to configure this option at all, because you are already getting the faster read and writes. Object checksum that I told you, these are the features of object checksum. Okay, you should keep it enabled by default. But if these all, your application is pretty much capable for object checksum, repair the objects and all, then you should not enable it. But ideally, we have seen most of the environment, it is enabled. Post provisioning, I explain you in a pretty much good way, where you have less sufficient host, less hosts, but still you are trying to apply the policy which require more than actual level host. Okay, you can do that, but that will not take the guarantee of the failover. Okay,
Sure. Okay, sir.
clear? So end of the day, whatever the option we have selected, it will showcase us like that. You
Summary
could
of
see
the.
if I'll apply thin provisioning, reservation is here 0, IOPS limit have been 0, site disaster tolerance is none. It is a standard cluster. It is a, so Banu, this is none means it is a standard cluster. Standard means a cluster which is being used in a single site, single data center. That is my none as a standard cluster. Okay.
Okay, sir. Yeah.
Now, like if we go back here, you have seen multiple option, है ना? Here you have seen multiple option. You have seen another option. See, when we configure the stretch, let's assume now you are in a stretch cluster. Okay. So stretch cluster primary function is why we make the stretch cluster primarily to recover the data if my any of the site got failure. End of the day, it is a single cluster. This is stretch across physical location. So somewhere I would like to see my data should be replicate on both sides. Okay, both sides. First thing. So it means that when I will select the first option here, stretch cluster mirror across site. It means that does not matter where my VM is, whatever data I will write end of the day under this VM object, it will create two copy. One is site 1, one in site 2. So it means that somewhere your data is replicating across site 1 and site 2. If I'll select the option first. Okay. And the second choice I have to choose this policy. This. So from where this policy is coming? This is from this option. If I have selected mirror my data across the site. Now, the second option from the policy tab itself, when we choose failure to tolerate type, this is telling me how you protect your data locally. If you have said again, locally, I want to apply FTT1 RAID 1, it means that what it will do locally? It will create again one more copy and one witness. Same way, one more copy and one witness. It means that now ideally you are protecting your data locally also, and you are protecting your data across the site. Now, if somewhere you have applied two policies, one is your PFTT that I code as across the site, that is my primary failure to tolerate that you are applying, mirroring across the site that you have applied PFTT1 RAID 1. First your data will be right across the site, then you have make another set of policy. This would refer as secondary failure to tolerate. It means that how you are protecting your data locally. Now you are protecting your data locally again by applying FTT1 RAID 1. It means that locally again you are protecting. So it means that if you are writing 10 GB of data within a stretch cluster with mirror configuration, how many times it will write? 10 GB here, 10 GB here first, then a copy of 10 GB here, a copy of 10 GB here. It means that your data writes 4 times, correct? So if I am planning my data should be protected across stretch cluster, first, my data should also be protected locally. I have to follow 2 set of policies across the site. I have applied FTT1 mirroring. Within site, I have applied secondary FTT policy, FTT1 read 1. Okay. So now it means that if I am writing 10 GB data, originally it's consuming the 40 GB. Okay.
Okay, sir.
Yes, sir.
Clear?
So where will be sorry, ma'am.
Yeah. So this the best use case of it. You are planning the stretch cluster across 2 availability zone where you want to protect your data across the sites. If one site goes failure, your VMs will be restarted on another site without any DR solution. In this scenario, you don't need to spend the money to any kind of DR solution, SRM and all. Got it? Your stretch cluster is protecting you against the complete site failure. Stretch cluster, don't worry, we have the entire module. But from policy perspective, I want to explain here. Okay. Now you will
Okay,
say,
sir. Yeah.
yeah. Now you should ask me, sir. That is fine. I am okay. But sir, I want. I am a stretch cluster. That is fine. I am pretty satisfied. I can protect across the site. That is pretty satisfied. Okay. But within for certain set of VMs, can I make, because I don't want overall protection, because by default, if you apply these policies, automatically my entire data will be replicated across the site and it will protect it locally. But sir, can I do something mix match? Mix match is means like, one second, I'm just looking for that blank slide, or I have to create again. Do I have choice? So I want to come back here. You see, why my site disaster? I just explain you this one, site mirror stretch cluster. Okay. But even I have a stretch cluster, I want to keep preferred data on primary site. I want to keep preferred data on secondary site. Or still I don't want, for certain set of VMs, I don't want the, I don't want to be data should not be mirror. Okay. So that you could make none as an stretch cluster. So again, you have different set of policies you can apply. For certain data, you can protect across the site. Certain data you don't want to protect across site, that is also possible. Certain data you want to protect locally. Certain data you don't want to protect locally, that is also option, because you have different set of policies together. Okay, so you can apply within a stretch cluster scenario itself across the sites. You can apply any of the policy. Within site, you can apply any of the policy. Okay. Again, it's all part of your planning and design, how you want to do. Like for example, across the site, you say, sir, across the site, I definitely want FTT1, RAID 1. It means that whatever data I will write, it should have a redundant copy. I do agree. Okay. But now you are saying, sir, locally, I don't want to keep as FTT1, RAID 1. I want to just keep FTT1, RAID 5. That's also possible. That is also possible together. So how it will do? Whatever data I learn here, data, data, data parity, because somewhere you will get the storage optimization. Okay, same way here, but it's not like that. Site 1 have different, site 2. No, locally it will apply similar on both the sides. So what advantage I'm getting if I'll compare it from FTT1 RAID 1, you are definitely saving. Where earlier you were locally consuming 200%, now locally you are only consuming the 133%. Okay, so whatever is available here, same will be available locally here. But local protection I have done through FTT1 RAID 5. Sir, is it possible to apply across the site FTT1 RAID 5? Answer is absolutely no. Because FTT1 RAID 1 you can do with mirroring, that's a possible scenario. But FTT1 with RAID 5 you cannot do across the sites. Okay, across the site either you should be protecting or you should not be protecting. That is also possible. Okay, in this case you will only write data locally. Locally means whatever written here, when the local policy apply, it will split accordingly, but my data will not replicate across the site. Okay. But what is the best case we have seen? Wherever we are protecting data across the site and we are planning the kind of DR solution, across the site, we always apply FTT1, RAID 1, and locally, for local data protection, we keep certain set like FTT1, RAID 1, also FTT1, RAID 5, kind of that for the data optimization. Those are the possible scenarios altogether. However, all are the possible scenarios. Okay, so it's all depend upon my planning and the way of I want to protect the overall data. Pretty interesting.
Yeah, yes, sir.
But
Yes,
again,
sir,
as
yeah.
I said,
Yeah.
lot of permutations and combinations are available, but it all matters on your planning and designing how we want to do that. Okay, execution is simple, but planning, initial planning and designing are something we have to think a lot and we have to give the desired solution for the customer. Maybe customer is saying, yeah, make a mix or match. Maybe one cluster make me stretch. I want minimum RPO and RTO for the, I don't want to spend on the any kind of DR solution. Out of that, make another cluster that should be standalone and just make the local protection. I will just configure kind of SRM or DR solution and I'll protect the desired virtual machines. Okay, that's also the possible thing. All right, so these all storage policies and all definitely will be learning within lab itself how we'll apply it. Okay, we'll see that different set of policies, placement, where my objects VMs are going. But definitely before that, we need the set of nodes and we should be keep the ready my vSAN cluster. Okay.
Okay, so yeah.
We are definitely covering that in hands-on part itself. So